Hello and welcome to the second derivative test of maxima and minima video from Wise Interactive Learning. So previously what we have seen, we just try to go through and revise. So in the previous chart we saw that for points A, B, C and point D, there were different moments for the previous and the afterwards graph. What do I mean by this? So before A graph the function was decreasing and after that point it was increasing. So we called it as a local minima point. Similarly for point C, and in case of point B, we saw that the left side graph was increasing and the right side graph was decreasing. In the same manner such as point D. So we said that the nature of graph for these points suggests that for the point A and point C, we can say these are points of local minima, and we said that for point B and point D it was local maxima, right? And we also went through some of these parameters, right, where we said that for the point of local maxima, let's say if the point was C1 in case of over here, then we said that if we equate it to f dash of C1 to 0, then we'll find a specific point which is a turning point, and we called it as a turning point. So at that turning point, similarly with point C2, we had to check whether the previous function coming after before it, which was f dash of x is greater than 0 over here, it should be greater, and in case of f dash of x which comes later, it should be less than 0 for the condition to satisfy if the point has to be the point of local maxima. So we have completely successfully done this, but we had few steps in order to do this. What were they? So for the first derivative test, we can say that first we tried out to find out what is f dash of x. So after f dash of x, we tried out to find what are the turning points by equating f dash of x to 0, which gave us two different distinct points or 3 points or sometimes 1 points, so on and so forth. So in the third step, we saw if the f dash of x is greater than 0 before or after it, or if f dash of x is less than 0 before or after the particular turning point, and those specific points gave us the exact nature or exact understanding of those turning points, whether they were minimum or they were maximum point of that particular function. Okay, so second derivative test is fairly easy, but in this particular test we are not going to find out what are the turning points. We have done that in the previous first derivative test. So why are we doing another test which is second derivative test? So it is, in plain simple English you can say that, to find out the maximum value or the minimum value of the particular functions. So by doing second derivative test, we are going to get assured that the values of it are going to be maximum or minimum. So in the first derivative test, what did we saw? In the first derivative test, we saw if the points, turning points, if the turning points are at maxima or minima. So those 2 points C1 and C2, so in this case I'll just show it over here. So in this case C1 and C2 over here, C1 and C2, these are the points of local maxima and local minima respectively, right? But we don't know what is the value of that function. So for example, if I take x square plus 1 plus 5x, let's say, if I take, like, if it is in domain of 4 to 6, right? If I take 4, then you can say 16 plus 1 plus 20. So this is going to be what, 36 plus 1, which is going to be 37. And if I take 6, then it is going to be 36 plus 1 plus 30. So it is going to be 67. So what did you see? In the first derivative test, we got to know what are the points. But in case of second derivative test, we are going to find out what are these values. So the values which tend to get when you put in the turning points are going to tell you the exact information about that function. So we'll try to check with 3 conditions how to find out what is the maximum and what is the minimum value of that function. So first condition, what does it say? If the function is twice differentiable at a point x equals to c. So let's take, if the point is equals to c, then what does it say? It says that if the point c is at local maxima at f dash of c equals to 0, and now here another important conditions come, which is f double dash of c, if it is less than 0, then value of function is local maximum value. So again, in case you need to keep in mind how to remember it, it is just opposite. So if we take maximum value, it is going to be negative, less than 0. Similarly, if you go on to the second condition, I am going to explain it again. What are these conditions? X equals to c for local minimum value at f dash of c equals to 0, and f double dash of c, now it has to be greater than 0. In order to find what is the local minimum value, f double dash of c should be greater than 0. It should not be less than 0. So if it is less than 0, it is going to directly mean that it is the maximum value. If it is greater than 0, it is going to mean that it is the minimum value. So in this case, then the value is going to be local minimum. Okay, and third one states that what if f double dash of c is equals to 0, right? So in this case, the second derivative test is going to be failed, and then we again have to translate our whole system and we have to check it by first derivative. So the first question over here we have, which is in front of you. Our first step is going to be very simple. F dash of x we are going to find out, which is going to be 12x cube plus 12x square minus 24x plus 0. Okay, so we need not write. Now what do we say? We have to equate it to 0 in order to find out what are the turning points. So we have 12x cube plus 12x square minus 24x equals to 0. We can take 12 outside, so we have common, so we have x cube plus x square minus 2x equals to 0. Now we can take x common outside, x square plus x minus 2 equals to 0. And now if you try to simplify it, it is very easy. So I'll just write it down directly. Plus 2 minus 1 equals to 0, and then you have x plus 2 and x minus 1 inside the bracket. Yes, so now you can see there are 3 different points where you can find out what is f dash of x when it is equals to 0. So what are these 3 points? So first point is when x is equals to 0, this whole term is going to be 0. Second, if x is minus 2, this whole term is going to be 0. Automatically all the fractions are going to be 0. So x is equals to minus 2, and the last one is x is equals to 1. So now we have 3 points, 3 turning points, and now we have to check with second derivative test. So first step was this, second step was this, and now we have to go to third step. So we have 3 points, 0, minus 2 and 1, and now we have to check what is the second derivative. So in third step we have to f double dash of x we need to find, which is going to be 12 times 3, 36x square plus 24x minus 24. So now we have f double dash of x in terms of x, but we have 3 values, 3 specific values, and those will give us directly what are the exact maxima and minima values and the turning points, and we'll just see how we can do this, right? So when x is equals to 0, when x is equals to 1, and when x is equals to minus 2. So f double dash of 0 is going to be, f double dash of 1 is going to be, and f double dash of minus 2 is going to be. So if we put x is equals to 0, what do we have? Which we have is minus 24, and what we have learned is if the f double dash of c value at that particular value, if it is less than 0, then this point is going to be the point of maxima, isn't it? So we'll take f double dash of 1 now. So if you put 1 over here, 36 plus 24 minus 24, it is going to be 36, which is greater than 0. So this is still a point of minima, isn't it? Now if we take x as minus 2, we can see over here 36 minus 2 squared plus 24 times minus 2 minus 24. Now you need to do some calculations over here. So 36 times 4, it is going to be 144, minus you can see this is 48 minus 24, which is going to be 72. So this is 72, which is greater than 0. So still this point is also a point of minimum. So now we can say that, see, if you see this condition and this condition, these are two different points which are local minima, but this point is of maxima, which is local maxima. So we can directly put the values of f of 0, so we can find out what is the maximum value of that particular functions. And if we put 1 and minus 2, we'll get the minimum values of that particular function. So we'll write down what is the function once again, which is f of x is equals to 3x raised to 4 plus 4x cube minus 12x square plus 12. So now when you put f of 0, you have this whole terms will get cancelled out. So this will be 0, this term will be 0, this term will be 0, and you will have final answer as 12. So your maximum value for this particular function is 12. So if you put f of 1, then what are you going to have? So let's put 1 over here. So this term you are going to have the value as 3, this term you are going to have 4, 3 plus 4, this term you are going to have minus 12, and then this term you are going to have value as 12. So plus 12 minus 12, it's going to get cut, and your final answer is going to be 7. So f of 1 is going to be 7. Let's take in case of minus 2. Okay, so in case of minus 2, this first term is going to be minus 2 raised to 4, it is going to be 16. 16 times 3, it is going to be 48. Now plus 4 times minus 2 cube, right? So this is going to be minus of 8 times 4, which is minus of 32. So we can rub this off and we can say this is going to be minus 32. Now minus 12 times minus 2 square, it is going to be 4. So this is going to be again 48, and then we have plus 12. So now watch carefully. Plus 48 minus 48, these will get cancelled out, and then we have minus 32 plus 12, which is going to be minus 20, isn't it? So now we have to compare two values. Okay, so first value is 7 and second value is minus 20. Now you know that f of minus 2 is going to be the local minimum value. So now we have found out in a simpler way how to get what are the turning points by first derivative test. Also we can find out what are the natures and if the points are maximum or minimum by doing the first derivative test and inserting the values which are closer on the left and the right side of that function. In the second derivative test, what have we found out? We have found out that if we need to find out what is the exact value of that minimum and maximum at that particular function, we need to find out f double dash of c, and we need to check if it is less than 0 or if it's greater than 0. In case of less than 0, this is going to be the maximum value. In case of greater than 0, it is going to be the minimum value. So in the next video we are going to solve exercise 6.5 of NCERT, and we are going to go through easiest and some kind of variations which are given in the exercises, and we'll try to find out how can we do maxima and minima questions within 1 to 2 steps. Thanks for watching and see you in the next one.